data layer should still be first, function layer should still be second, action layer should still be third. If you want to scrap out the presentation layer, you don't have to, but you still want to include a polish layer, that's fine. Most of the time, I think you'll only need 1, 2, 3, 4 of these letters. Presentation layer is optional. So again, it still comes back to DFAPP. Don't get it confused with fapping in general, but yeah, do people even still say fapping? I don't know if that's a thing anymore. But yeah, what's going on, everybody? Welcome to another Granulariti tutorial, monologue, brainstorming, whatever you want to call it. Today, again, we're going to talk about something that is a bit more progressive, a bit more abstract, but very relevant to the time that we're in. Last video, I kind of also talked about taste, which is an abstract concept, and adding taste to the AI products that you might create. And I think now that language, written language, is becoming the programming language of the future, I do believe that taste is more important than ever, right? You can easily give more of a description, give more context into how you want the app that you're building to operate, how you want it to be shaped, so forth and so on. So today using I guess GPT Codex from OpenAI within VS Code, it's Copilot, we are going to vibe code an application. Now, this application is very relevant to the times that we're in as well when it comes to text to SQL. Very important, very useful when not only trying to pull data, but also very relevant when trying to pull data to then showcase it in a digestible visualization for people. So we're going to use Google Gemini in this. We're going to use Streamlit in this. But again, more importantly, we're also going to use the written language. And I'm also going to provide you a framework on how to vibe code. I think and I believe that there are plenty of influencers, teachers, educators out there that have this idea of like just plug in an entire prompt and list out, instruct kind of what you want to be built and then refine it after. And what I'm saying is I think we are not breaking it down enough, where the prompt itself should not be one large instruction, but should be broken down. When you are, think of like when you were in school, right? When you were first learning, let's say when you're first learning multiplication, they didn't automatically just throw multiplication at you when you were in kindergarten or when you're in elementary school or primary school, whatever kind of school. Instead, probably they threw addition at you at first, right? And they're like 3 plus 3 equals 6. 3 plus 3 plus 3 equals 9. And then based off of that, right, maybe you'll do like, I don't know, like now it's, okay, well, 3 times 2 is 6, right? You get 2 3s, you add them together, that equals 6. 3 times 3, 3 plus 3 plus 3 equals 9. So what I'm trying to say, you had gotten a bite-sized chunk of a subject before you got into a larger subject of multiplication, where addition kind of begins to grow into multiplication, right? You need to understand the basics before you can understand the entire macro concept. And I think AI is the same way. AI is still in its infancy. I'm not going to go on talking too much. I know we're on almost 5 minutes, but AI is the same way. You don't want to feed AI your instructions in one chunk. At least I don't believe that's the way to do it when you are vibe coding. Maybe for research, for other tasks, maybe, yeah, you do need that. But for vibe coding, I don't think that's the case, right? So we're going to kind of go into how to instruct AI when vibe coding to build out applications the first time with ease versus giving an entire prompt where the model can become confused, where the model doesn't always get context and doesn't always know exactly what you want. But if you can break it down, less confusion, more context, and it's easier to kind of build that taste. So let's jump in. So the first concept I want to spell out for you guys is something called, let me make this bigger. It's something called, can you see it? Yes, there it is. Here we go. Whoops. Is it going? Hopefully soon. So there's something called, got some notes here for you guys, just so I can keep track, but something called progressive complexity. Now, progressive complexity usually is used in product development talks, usually used in design talks when you're talking UI applications, UX, stuff like that, where think of when you click on an app. Let's take the settings app in your iPhone, right? And I think this is a prior conversation we had in a past video, but the iPhone's a great example where once you log in your passcode, face recognition, whatever it is, into your iPhone, you then get presented with these small pieces of apps, right, that look pretty welcoming. And let's say you click on your settings app and it shows up an entire list of choices. It's not just, bite-sized choices. It's an entire list. And it's not even the full expressive list of what you can pick from, right? You have to pick from this limited list of choices in the settings to then go to a larger list that can possibly give you more optionality of what you want to do. Same thing like if you click, if you go from clicking the settings app, then you go to clicking the display option in the settings, you then get presented with even more options for settings of brightness, wallpaper, accessibility, stuff of that nature, right? Lock screen. It presents, it's like the Russian doll concept where one thing turns into something bigger or something more, then you get more of it, then you get more, and it kind of multiplies or factorials on itself. That's kind of the concept that I think progressive complexity is. Also, I think progressive complexity is used in education, right? Same thing with, I think you kind of need to have a good basis of addition before you can jump to multiplication. 3 plus 3 is 6. And if you know that 3 plus 3 is 6, and you go to 3 times 2, you can say, okay, well, that just means that I need to add 2 3s to also equal 6, right? Addition builds on multiplication. And then, again, after that, I'm assuming like you can go from addition to then multiplication to then exponents and powers and then polynomials and go on and on and on and on and on. And again, it just builds on itself in that complexity. So progressive complexity is something that we are going to use in our vibe coding app building. Now, when you think of progressive complexity, I want you to think of also your own brain, right? Where AI itself is your external brain, and you don't want to overload it with information. Similar to how in education, you don't want to overload a student with information, right? Cognitive overload is a real thing, which I think even now it's more relevant than ever. Same thing with AI. The minute you plug in a full list of instructions all at once into an AI model, there's a high chance it will not get it the first time. And then you have to iterate and iterate. And there's higher chances that after those iterations, it'll get things more and more incorrect. So I'm saying break it down. Just like you would want multiplication, or we can go all the way to polynomials, just like how you would want polynomials broken down for you, I'm sure you would probably want, or I'm sure AI would probably work better if the instructions were broken down as well, so that it can handle these complex tasks as it goes. So, few concepts here that I want to kind of point out is, can I remove this? Go on. So we have progressive complexity, and then we have cognitive overload are two things that you want to pay attention to when you're vibe coding these applications, when you're trying to create an app using vibe coding techniques. Pay attention or keep in mind of these two things. Again, you don't want to overload with instructions unless you're doing some type of research task. I think that's the only time you may just want to give it a full list of instructions, and then you can let it bring back whatever information and then ask questions against that information. And then progressive complexity is also something that you want to pay attention to. But anyways, let's jump to the actual demo. So just like before you build I always kind of like breaking it down in examples, right? Where let's say you want to build a car. Let's say you probably want to build a Ferrari, a Bugatti, whatever your favorite kind of dream car is, Porsche. The first thing that you kind of want to do is have an idea of what the frame could look like, right? Because in order to maybe stuff the engine, the gas tank, the alternator, the battery, the whatever it may be, you kind of need to have an idea of how much room you have to work with. And you kind of want a skeleton, a frame for this information, or for these components of a car that equate to the information that we're going to use for our app that we're vibe coding. Same thing here, right? So we're going to go to our GPT Copilot here, and we're going to say that we want to build the skeleton first. We want to create a Streamlit app that uses Google Gemini to convert natural language questions into SQL queries for a clinical trial database. This is us building out that frame. This is us building out that kind of skeleton to give an idea of what the overall idea of what we want. And then this is that progressive complexity, right? We're giving the idea of what we want, and then we're going to break it down. We're giving the idea, again, this is an example. We're now giving the model, we're now presenting the AI model, the idea of a car, right? After this idea, we then are able to tell the model, or let's just say you have an engineering team, we're then able to tell them, now that we have the idea of that we want this car to drive really fast and look really good and sexy, we now need to figure out how to make it do that after this first iteration or after this first idea, after we kind of lay out what we want. So this is us doing that, where have a sidebar for API key input and schema display. Use an in-memory SQLite database with these tables, studies, sites, subjects, visits. Populate the mock data for 2 studies with multiple sites and subjects. Use Google-Gemini SDK with client for API calls. Set page config with title clinical text-to-SQL Gemini, and have a DNA icon in the mix. That's what we want first. And we also want to make sure we state this has to be within our .py file here. So let's let it go. Ooh, one more thing. I think it's still on agent mode. Yeah, okay, cool. You want to make sure it's in agent mode, by the way. I don't really care for the full access piece, but the agent mode is important. Let it run for a little bit. It's thinking. So as you can see now, it's created a Streamlit app in VBCD text-to-SQL that sets up the in-memory clinical trial database, seeds mock data for 2 studies, uses Google Gemini to turn natural language questions into SQL queries, blah, 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 blah. As the icon, add guardrails to, if you want, I can also add guardrails to block non-select queries. We don't really need that just yet. I think we're just going to go with the prompts that we have already. Switch the model name or make it selectable in the sidebar. Sample questions, da-da-da-da-da. We're not going to go into depth like that. I kind of already have a set prompts that I want to use. Let's just see what we create first, and then we can tweak it after if we think it needs some tweaking. But as you can see, right, SQLite is here. It's installed everything from SQLite, Streamlit, Google, created the connection to SQLite, created the mock tables, the schema for us, seeded the data. As you can see, here is, I think these are the subjects, high dose, into subject, subject ID. Okay, so these are subject ID, study ID, site ID, screening, randomization, ARM, and status. Cool. Screening, baseline, blah, blah, blah. Generate SQL. You are a data assistant that converts clinical trials questions into SQL. Return only a single SQLite compatible SQL query without formatting. So personally, right, my take is, if everything in terms of the data looks good, right, if this is kind of doing the job that you want it to do, the prompt is the main thing you want to worry about, right? Because the prompt is ultimately how the model will act when it is encountering a user's query and putting it against the data it has, right? So cool, we're using Google Gemini, blah, blah, blah. Run query. Clinical, as you can see, page title, icon, layout wide. Ask a question about clinical trials, Adds an example question, how many active subjects are enrolled per study. Asks the user to enter an API key. 2.0 Flash. Cool, okay. So now we have, let's just say, the skeleton. We have the general frame of what we want, right? We have the database, and the data that we want to kind of have in it. We have the UI kind of shaped here a bit, right? Adding the title, the icon. We don't see anything just yet, right? It's not working. It's not running. It's not, the motor isn't turned on just yet, right? For this engineering contraption to run, but we have the idea of what it's supposed to do. Next, right? We want to add the text to SQL function. That is the part that is going to be probably the most important, or I think second most important in this application. And so the prompt I'm going to use, like I said, I kind of already had these prompts written out already, so I'm kind of just copy and pasting. Feel free to use these same prompts, by the way. Maybe I can provide them in a free way. But add a text to SQL function that, number one, takes a model/client natural language question in schema description, sends a prompt to Gemini and we're specifying in this one as well to use the Pro Preview model, Gemini 3 model, versus the 2.0 Flash is using here, which is fast and that's cool, but we kind of want something more accurate and more relevant. System instructions, database schema, user's question, and incorporate all this into the prompt. Temperature, handles both Google client and legacy generative model objects, extracts text, strips markdown, blah, 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 returns clean SQL query string. So the reason why we're using Gemini instead of ChatGPT, I think I've grown to become a Gemini fan. I used to be 100% a GPT fanboy, but I think now Gemini has been surprising me a lot. And so my take on Gemini these days is pretty positive. But this is where we begin to create the brain of the application. This is where we begin to establish at least the specifics of the engine. One thing I want to take to you guys, or give to you guys, I'm sorry, is if you know Maslow's hierarchy of needs, which I think is something that's been here for a while, there's also like a big data Maslow pyramid, right? What makes AI, right, super cool to do is it's able to process information, data really well, and turn that data and that information into potential knowledge for anybody, right? In a synthesized, digestible way, if you ask. That is most important, and that's why I think that's where AI really meets a clear need, right? Is even with this, right? Vibe coding takes the ability for anyone to use written language and communication in a digestible format, in a useful format, in an understandable format. Use the language to build apps, right? Gemini or AI in general can be used to take data and information to build knowledge. Same concept, same methodology. Let's kind of press enter and see what happens and how it builds it. Also, I think I have the reasoning set to medium. I never really tried high or extra high. Basically, when you go to high or extra high, the longer it takes. I wouldn't really recommend it. I'm using the 5.2 codex. I think I was using the codex max before. I'm waiting for a 5.2 codex max to come out. But yeah, 5.2 codex is what I'm using. And now again, right, we let it think, we let it process. And as you can see, it's kind of begin reasoning. I'm creating a new function for text extraction to handle both client types and updating the main flow to use it. Let's give it some time and see what it spits out in a bit. Cool. So that was actually pretty quick. Added a text SQL helper that supports both Google Gen AI client and legacy generative model. Uses Gemini 3 Pro preview with temperature 00. Let's see if it made that change real quick. Where is it? Models, maybe it's set up here. Temperature ... 0 models. Oh, here it is. Gemini 3 preview. So as you can see, it did make the change, right? It did what we asked. Setting the temperature to 0 for Determinix output. Changed it from 2.0 Flash to 3 Pro preview. Also, make sure you have a Gemini API key. This will require a Gemini API key in the end. Just keep that in mind. So we still have our app. Everything still looks the same. Ask a question. Still has the DNA marker or DNA icon. Here's the changes that it made. It lists them out. Blah, blah, blah. Database schema, temperature. Cool. So now that we kind of have that function, we also want to see if we can express visuals in this next. Visuals, okay, worded responses are really good, right? And I think this is like a known factor when it comes to visual analytics. If you ever played with Tableau, Power BI, ever come from like a business intelligence background, you know what I'm talking about, where it's always told that worded responses work really good. Let me take that back. Worded responses are not always the best, actually, because when you talk percentages, when you talk numbers, when you talk data, it's hard to piece it together for a lot of people. It can become very confusing. But if you can lay out this information in a visual medium, that is super helpful for anyone to understand, okay, that circle is bigger than that circle. Clearly that means, that circle probably is more of something. That part of the pie is larger than that part of the pie. Clearly that percentage is larger. That bar is bigger than that bar. That must mean that that bar is bigger in some capacity, right? Very easy to understand when you include shapes with numbers. It's funny. It's very elementary, but shapes really do help in explaining concepts when it comes to data. Known fact. So this is where we kind of begin to establish like how we can create those chartings, whether it's a scatter plot, bar chart, histogram, and then be able to explain that charting in a visual manner. So here's where we begin to create functions that are going to be used to process the SQL, bring back the data needed, and then create that visual for us. So add these functions. Run natural language query or run LO query combines text to SQL with pandas read SQL query, returns data frame of the data that we're trying to see from the SQL, visualize the results, auto creates plotly charts based on column types, scatter plot, bar chart, histogram, return none if no suitable visualization, build schema description, yada, yada, yada. Cool. So Query center, pragma table info to generate schema text. Nice. So now we want to build the visualization and see what it pops out from the other side. Let's go ahead and run it. So now we see where it added the other functions needed when it came to visualizing certain pieces. So the run NL query is here. The visualize results query, or not query, function is here. And numeric data type, data frame columns, if numeric is data type, categorical columns is numeric data frame call, scatter, return. If numeric columns, return scatter plot, categorical, if numeric columns, return bar, grouped categorically, title, blah, blah, blah. If numeric columns is equal to 1, histogram, data frame, numeric columns, I will also advise making sure you read over the code that's generated from these vibe coding tools like Codex, right? If you have knowledge of coding, if you have knowledge of Python or any kind of, even like, I guess, any object-oriented programming languages, that doesn't have to just be Python, maybe C++ or C, like, read over your code, at least skim over it, at least see kind of what it produced and make sure things are correct. I am someone who will always tell you not to trust AI fully, not because I believe it's going to turn into Terminator or some type of RoboCop, but simply because I don't think I know AI does not have the best judgment, right? What makes us special as humans in comparison to AI, again, if you my prior video, is our ability to have judgment and taste, is our ability to say, no, take this out, no, put this in, I don't think that works, I hate that color, the reason why I hate that color is because it's too bright. I think now in this AI age, you kind of have to have a designer's mindset, a designer and a writer's mindset. You don't just want to have this strictly analytical fixed mindset anymore. It's cool to have that, but you need to find a way to mix these things. I think people who are very stagnant, I shouldn't say stagnant, but people who are very, I guess fixed is the better word, very fixed in their point of view of, no, I like being analytical. I don't want to step into this realm of UI or UX experience, or user experience. I kind of want to remain in this engineer space without having any kind of creative or designer mentality. I think in this age, you're going to fall short every time. You just are. Especially, again, with vibe coding being out here now. And now designers really and truly have the power to hop into Codex with very little to no coding experience and create something beautiful. So all the engineers out there, I'm putting you on notice, learn how to create something beautiful. Please have some type of creativity, have some type of artistic mindset, study certain artists, study certain designers, really get out there and do some research. Anyways, as you can see, it's added these Plotly pieces here, added the packages. I think I've already showed you guys where it's added the run NL query, visualize results functions to express the data, and then pass that data to the Plotly to then visualize that data. So now let's move on to finalizing certain pieces, right? This is where kind of the fun part begins when we're almost done. This is kind of where we begin adding the little tweaks and the little nuances to things when it comes to buttons and clicks and just how things are visualized, text areas, text boxes, input boxes, things of that nature. This is that. And this is where we kind of are on the verge of completing it all. And we're kind of, again, just adding the creative tweaks to it. So here's where we complete the main function here. Complete the main function with text area for natural language questions, default in the text area, show enrollment per site, including how many subjects are randomized and screened. Run button that calls Gemini, executes SQL, and displays, again, talking buttons here. And here is what it displays, runs results, error handling, a spinner, right? Who would have thought like, hey, a spinner should be added, and examples in sidebar showing sample questions. Again, this is just for users if they don't really know what to ask. We have examples. So let's go ahead and run this and see where it gets us. Again, you want to have a Gemini key for this. I just want to make that a point as well. Okay, so we can see that it did include sample questions here. Show text area, show enrollment per site, including how many subjects were randomized. Cool. We see that it added the spinner as well, generating SQL and running query. So again, easy as pie, right? I think it's now 30 minutes, but the only reason why it's 30 minutes is because I've been talking. You can probably cut this in half and do it in 10 to 15, realistically. As long as you set up your prompts correctly first, kind of have a general step-by-step. I think you can generally do things in 4 to 5 prompts if you have it in a step-by-step format of clear instruction. And again, you can have certain AI models help you formulate these instructions better, then pass this on to your vibe coding cursor, ID, whatever tool that you're using, assistant. And it can kind of build this out for you. So, but now, right, we want to begin adding the cherry on top, right? The small refinements that make a big difference when it comes to cache or caching, when it comes to error handling, when it comes to helper text, when it comes to storing a CSV, adding fallback logic. This can be really helpful in this application to make sure that we're not cutting corners and that we're actually keeping in mind of what could happen, what possibilities, user errors that might happen, stuff like that. So let's go ahead and add a few things. And this is the last prompt. Then I'm going to kind of give you guys my little theory and framework of how I'm structuring my prompts from now on. So cool. It added these small refinements. When it comes to cache, PD, data frame, configure Gemini, set, check same thread, cache, store CSV and variable clinical CSV. They do that. Let's see. InitDB. I see it here. Download CSV, stored as clinical CSV as data, CSV text. Okay. Cool. Add fallback logic for older Google Generative AI SDK versions. Now, the main part that we're all excited for is, does this even actually work? Will this even actually work? And I'm here to tell you, we are going to give it a try and see what happens. Now, so here is our test real quick. We're going to do new terminal, pi-m. Does anyone else feel like they have to do pi-m for Streamlit these days? I don't know if it's just me if I'm doing something wrong, or maybe I need to update my Python version, but I've been having to do that every time I gotta run Streamlit. Maybe someone can help me in the comments with that. But here is the app that we get. Hopefully everyone can see that. Is we see that it's running localhost 8502. Again, you're going to want to have a Gemini API key. Don't want you guys to see my API key, so we're going to have that there. And here's the general app. It is missing the, oh, here's the icon. I thought I was going to include it here, but I guess it included in here. That's fine too. It doesn't matter. I thought I did say, let me see, icon. And like I said, this is where you begin to realize Set page config with title. Okay, page config. I see. This is where sometimes you can't always trust AI, and where you should really, again, make sure you read and make sure you look through your logic to see if everything is okay. But let's try a question real quick. We're not going to try the default example that it has. Instead, we want to try our own novel one. And it is show total number of subject per phase. Subject, oh, let's do subjects. Show total number of subjects per phase over time. So what I'm thinking is it should either be a scatter plot or bar plot that it should come out with, but we just want to kind of run down and see what it produces. And as you can see, it generates a SQL. Select T2.phase, T1 randomization date, count from subjects as T1, join studies, blah, 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 blah. Beautiful. And then we get our results. Phase, I see 1, 2, 3 phase 2s and 1, 2, 3, 4 phase 3s with randomization dates, with a visual of a bar chart of, hey, there's clearly in phase 2 there were 3 subjects, clearly in phase 3 there were 4, and now we can download the CSV and see the raw output. And if we want to, we can have the CSV, download it. I don't know if I'm able to open it. Let me see. I don't have oh yeah, I am. Okay. I don't have Microsoft Excel. There you go. That's what I wanted to see. Get out of here. No, I don't want to buy your product. And as you can see, it comes with kind of the same information that's expressed. Where'd it go? Well, I guess after you download it, it goes away. But as you can see, it comes out down with the same information that was expressed prior. But again, like you said, this is a tweak that you got to work on, iterate, but you have the whole idea of the application. Now it just comes back to, well, after we open that Excel, we kind of don't want it to refresh. We want to keep the same information that we had before. That's something that you can tweak over time, but you have the general application that you can then refine and add your own kind of refinements to it. So with that being said, I'm going to bring back up another concept. I'm going to bring back my whiteboard real quick, and we are going to kind of delete some things. Come on. There you go. Come on. Come on. Why? There you go. Make it so difficult. Sorry for taking so long. So now I'm going to give you a theoretical concept that I have, right? In school, you probably learned something called order of operations, right? And probably, I think for everyone, I don't know if it's just me, but probably for everybody, they learned something called, I'm taking you guys all the way back, something called PEMDAS. PEMDAS, which is, I think, parentheses, exponents, multiplication, division, addition, subtraction. I think that's how it goes. Parentheses, exponents, multiplication, division, addition, subtraction. If I'm getting this incorrect, please someone correct me in the comments. Don't drag me too hard, but I'm pretty sure that's what it is. I believe in an order of operations kind of needs to be said for vibe coding. And I'm going to, I'm not going to give you the acronym just yet, but let's say for vibe coding, right, we have the data layer, which we established in the beginning. Not only do we have the data layer, but then the data layer should lead into the function layer, where we establish our functions that we want to use. And then from the function layer, we have our action layer. Sorry for looking on the other side. I have all this stuff written down. Right, and then we take from the action layer. Didn't feel like going over that word. Then we go from the action layer to where we have our presentation layer, which is the visuals, how we want to show the data, how we want, or if we want to show anything in our application. Again, these aren't like definitive things. These are just if you encounter, if you have this idea of you want to kind of develop something like I just did just now, I think it's preferred that you would want to follow this kind of order of operations I'm showing you now. This is something I came up with. I think there's another acronym called SMART that I think is how to kind of do prompts and how to structure your prompts, but in one shot, right? This is more so like, I guess, in a few shots, right? 1, 2, 3, 4, 5, 6, 5 or 6 shots, I think, where you do like each one is a different prompt itself. So we get presentation layer, and then we get polish layer. And this, again, is where we have our refinements and whatnot. So data layer, function layer, action layer, presentation layer, polish layer. I think that's what I written down. Data layer, function layer, action layer, presentation layer, polish layer. Yeah, cool. Okay, so data layer is what we did in the beginning, right? We established kind of what we want our mock data to be, what should the contents be, so forth and so on. Then we establish how we want our functions to go when it's processing this information, and that's where Google Gemini came in, right? Then we have our action layer, right, of what it's supposed to do with that information and what it's supposed to generate from that information, right, which is the SQL. Then we get the presentation layer, plot leads, the visualizations, so forth and so on. Then we get the refinement layer or the polish layer where we have like the cache and the buttons and the spinning pieces. That's where I believe how when you are vibe coding apps, this is what I believe you should follow. I think it's the easiest for me. I think it's the easiest for thee. And I believe it could really help you. And to kind of remember this, I came up with an acronym, just taking an easy acronym, just taking the first letters of each, D, F, A, P, P. Now, what this is going to spell is something relatively dirty, but please, this is a PG-13 space. Try not to get too disgusting. So we're calling this DFAPP with 2 P's. D, data layer, F, function layer, A, action layer, P, presentation layer, P, polish layer. DFAPP. I think it's the easiest. I've been using this kind of thing that I believe I'm the first to come up with. I don't know. It's just easiest for me to think through how I want to create applications when it comes to maybe that have a visual piece in it and that have a piece that I kind of want to do. Now, you can interchange this, right? Maybe you don't necessarily need a presentation layer, but you still want to polish it, right? Maybe you just want to have a data layer, a function layer, and an action layer. So you only want to use the D, F, and the A. That's fine too. You don't necessarily need the P, right? Just like in PEMDAS, right? If you only have parentheses and exponents, you only use the first two. As that's kind of the first things in this list of order of operations. If there's no parentheses, if there's no exponents, but you see some multiplication and you see some division in a calculation, do these two, do multiplication first, then do division, and so forth and so on. Same concept, right? Data layer should still be first. Function layer should still be first. Action layer should still be first. Data layer should still be first. Function layer should still be second. Action layer should still be third. If you want to scrap out the presentation layer, you don't have to, but you still want to include a polish layer, that's fine. Most of the time, I think you'll only need 1, 2, 3, 4 of these letters. Presentation layer is optional. So again, it still comes back to DFAPP. Don't get it confused with fapping in general, but yeah, do people even still say fapping? I don't know if that's a thing anymore. But yeah, DFAPP. Remember that. Hopefully it helps you just like it helped me. And hopefully it helps you to create effective apps when vibe coding. And with that being said, bye-bye.